Hi everyone. So now we are going to talk about electromagnetic waves. So as you know, it's a very simple topic. I mean, a small topic, and the gravity of this topic is also very less. Anyways, we'll discuss this. So we'll take 1 hour and less than 1 hour, and we'll discuss the including problems. Okay. All right. So first of all, what are EM waves? So this is here I have given a picture, so you can check this. You must have seen this before. And the idea is, like, suppose there is an electric field here and magnetic field here. Okay, so there is an X, Y, and Z direction. So if an electric field is in a uniform electric field which is there, and there is another magnetic field which is at an angle of 90 degree with the electric field. So it's not uniform. I'm sorry. Okay, so that is the first thing you have to know. And second thing you have to know about that, like, if the electric field is changing, then it will produce a magnetic field. If the magnetic field is changing and vice versa, the magnetic field is changing, which means it will produce an electric field. So a change in electric field can produce a magnetic field, or a change in magnetic field can produce an electric field. Okay, so this is what is the idea of electromagnetic waves. So that process which gives the rise of a transverse wave, a particular transverse wave, that is known as electromagnetic wave. Okay, and let's talk about electromagnetic wave. So again, a change in electric field produces a change in magnetic field, or a change in magnetic field can produce a change in electric field. So this process which gives us the rise of a transverse wave, which is known as electromagnetic wave. So we will discuss about the properties of electromagnetic wave. Look at this. This is in the y direction, electric field. I have shown it like this. Okay, and on the z axis, this is what is this? Magnetic field. So where will be the electromagnetic wave? Electromagnetic wave will propagate along the x-axis. Okay, electromagnetic wave will propagate along the x-axis. Alright, so again, I would like to tell you something. That is, how did we get that it is propagating along the direction? Because the direction of electromagnetic wave is always in the direction of E cross B. Okay, we have learned it. It's a screw rule, right? So E cross B. So there is E along this direction, and at 90 degree angle B is there. So E cross B will be in the perpendicular direction. So if this is E and this is B, then E cross B will be in this direction. So that is first thing you have to know, direction of propagation of electromagnetic wave. Second thing, the electric field in this electromagnetic wave, that gives us the optical properties of that electromagnetic wave. Again, the electric field in the electromagnetic wave, so that gives us the optical property of that electromagnetic wave. So that is why E vector is called as light vector. Okay, electric field vector is also known as light vector. Again, electric field and magnetic field are in phase. Okay, so we have learned about waves, right? So in waves, what is in phase, out of phase, like etc. Or the phase difference is this much. So here E and B are in same phase. They are in phase, or there is no phase difference between them. Alright. So again, we will discuss. So suppose electric field vector E is equal to Ey, because it's in the y direction. E0 sin kx minus omega t. And what about B? Bz is equal to B0 sin kx minus omega t. So these are the things. Look at this. The phase difference, phi is equal to 0 here. Okay, what is k? K is nothing but 2 pi by lambda, wave number. Alright. And what is E and B? E and B are the instantaneous values of this one, electric and magnetic field. Instantaneous value. What about E0 and B0? Those are maximum value or amplitude of this one. Amplitude. Okay, this will be E0 and this will be B0. Alright, amplitudes of electric field and magnetic field. Alright. So these are the things. Okay. So these are the basics of this one, electromagnetic waves, and we will discuss about the production of waves and the spectrum, etc. Anyways, so before that there is one more topic in this. So that is Maxwell equations. Maxwell equations. So Maxwell equations are actually like there are some equations in electrostatics and magnetism. We have learned some particular equations and laws. So there is Maxwell has changed or Maxwell had given another perspective of these equations with respect to electromagnetic waves. Okay, he considered the electromagnetic waves or the idea of electromagnetic waves over here. So my question is, look at this. My point is, what are the changes that the Maxwell had made in these equations? Okay, so he had changed a little bit, and we have to discuss each one. So it is actually very easy. You just understand it, and some of the equations are exactly like almost similar to the other one, and nothing is changed. Nothing has changed here except Maxwell-Ampere's circular law that we will see. Okay, so first one, surface integral E dot ds equal to q by epsilon 0. What is it? Gauss's law in electrostatics. Okay, I am not going to discuss all these things because we will discuss about these equations in coming videos. I mean in electrostatics. And second one, integral B dot ds, surface integral B dot ds is equal to 0. That is Gauss's law in magnetism. Okay, integral B dot dl is equal to minus d phi by dt. What is that? Faraday's law of electromagnetic induction. Alright. So the final one is very important. Suppose suppose I have considered a capacitor. Alright, a capacitor. So there will be a charge storage here, right? So when you consider the current passing through this, there are two currents. Okay, according to Maxwell, there is an additional current over here that is known as displacement current, ID. Displacement current. What is the normal current we have? That is known as the normal current we have. That is known as conduction current. So there are two currents: conduction current and displacement current. IC and ID. Okay, IC means conduction current. In Ampere's law, only Ampere talked about the conduction current, but Maxwell had included the displacement current as well. So that is what is Maxwell's displacement current. Okay. Alright. So why there is a current? Because Maxwell assumed that there is a charge is flowing inside this plates or in between the plates. There is a charge flow over there due to the electric field. So there is a charge flow. Maxwell assumed that. So that current is known as displacement current, ID. Okay, that current is known as ID or displacement current. So what is the equation? The equation will be integral B dot dl is equal to mu 0 IC. What's the initial one? Mu 0 IC plus ID. Mu 0 IC plus ID. That is the new equation. So what is ID? ID epsilon 0 d phi E by dt. ID is equal to epsilon 0 d phi E by dt. Okay, so this is what is Maxwell's Ampere circular law, and there are different equations as well. So now we will see the production of EM waves and electromagnetic spectra, etc. Alright.